Good morning, good afternoon, good evening to people around the world. This is your host of the DB2Night show, Martin Hubel, and we are at show number 239 of the shows we've done for the DB2 LUW community, and we thank you for being here today. I've got yet another wonderful special guest with me today. Satya Krishna Swami is here from California. He had to get up early to be with us today. How are you doing, Satya?
I'm doing fantastic. How about you, Martin?
Oh, it's just great. It's a wonderful, sunny, warm day here. In Fahrenheit, I think it's about 55 degrees outside, which is unusual for November. Bright sun. So life is good. No snow yet. The snow, if you go about 200 miles north of the city, you can find quite a bit of snow up there now, but not right here because we're in the banana belt of Ontario.
That's awesome. So I won't complain about the snow since I'm on the West Coast, so I enjoy the weather.
You guys don't even know what snow is in California. We're around SVL. That's great. Okay, let's carry on here. And then for our European audience, when I said 55 degrees, I really meant 12 degrees Celsius because I'm bilingual. I speak both. Let me just get through the introductory slides, the things that we always do. Reminding you that if you follow hashtag Db2Night, you'll get information on upcoming shows and when replays are available. So hashtag Db2Night is your source of information about the show. LinkedIn group is there, and the YouTube replays are going up. People are looking at the replays more and more. I'm just noticing the counts I get in from that platform, and it's a great thing. Next, of course, is our disclaimers. We have trademarks. We respect them. They belong to the respective organizations, and we record, and your participation will be recorded. However, of course, you're muted, all of you, except for Satya and myself. So we'll carry on, and some other quick announcements. I'd like to let you know that through the end of January, I've lined up all the speakers. It's about time I did that, but it's all done. And I'm also looking forward as well into the second half of the year. And we've got some great speakers that will join us in the second half. Just to point out the upcoming shows, next week is on ZOS. And that's Roy Boxwell, a very popular speaker from the software engineering group in Germany. Roy himself is a former British subject. Now he's a German citizen. And he's speaking on esoteric functions in DB2, which means all of the little things that will be very, very helpful to you that you don't hear a lot about. So that'll be a great show. Next month, we've got another user speaker joining us. Jim Bean has been frequenting user groups and iDoug as a speaker, and he is going to come up with the best of his past presentations plus some new things. So I think you'll find that interesting. Jim has in a performance team there, so they have some good things to say. And in January, John Hornibrook will be back to see us, and John works on the optimizer in the IBM Toronto lab or in Markham. That's part of the joy of Toronto. It's we call it around here, we call it the Greater Toronto Area, or the GTA for short. I know in Chicago they call it Chicagoland, but John's been a popular speaker and he knows this stuff. Then in February, there's something that IBM is announcing in December, so I'm just calling it new stuff for now. And the director of the IBM Toronto lab will come back and join us again. We're always excited to hear it right from the man, and Piotr Mierzejewski is that guy. So please join us in February to hear that. I also can let you know as well that Piotr is a very big supporter of the DB2Night show, and we'll have many other great speakers on DB2 LUW in 2022. So, and then we have other speakers, of course, down here. Sonia and Patrick Bossman will be joining us on other as IBM speakers on DB2 for ZOS. So some really great shows coming up. Looking forward to seeing them. As always, DBI is the primary and founding sponsor of the DB2Night show, and they do have Their tuning video is available. The demo is available off the DBI site. There's the link. You follow it all the way through, you get a gift card of some sort, as I recall. Well worth watching if you're worried about DB2 LUW performance. Congratulations to our winner of last week, David Albin of American National. Got himself a gift certificate for participating in our studio audience. And again, our sponsors, DBI and yours truly. And we're to the point where we will do our morning polls. We've got 6 of them for you today, so follow along. And let's see if Martin does this correctly. I only buggered it up recently, only just once. But I figure the year is still quite young. There's still more opportunities for people to make for me to make mistakes. So we're giving people a chance to vote here, and we're getting along. I'll give you a couple more seconds to vote, and then we'll close her off. 3, 2, 1. Close, share, and there we see that our good look.
So that's a good number on 11.5.
Yep, we got many more people on 11.5 these days, and that's a great thing.
Yeah.
I remember the days when I was running this show and we had DB2 8.2 or earlier. That was quite some time ago. Close that off and move along. We've got our next one. Which operating systems do you run DB2 on? We've got the usual suspects there. I always thought that nobody would run DB2 on Windows in production, but my mistake.
We don't have a lot of customers on. Yeah, that is correct.
Yeah, my mistake. There's an awful lot of people out there. Given the opportunity, we normally are pushing Windows customers to consider a database server on Linux, but hey, Windows still works for me on when I'm teaching, that's for sure. So with that in mind, we're up to 92% of the people voted. We'll share the result there. You can see a pretty wide.
Yeah, kind of expected. Yeah, a lot of Linux and AIX.
Yep. And we'll do the next one, which is what platforms do you use in terms of installing DB2? Native installs and cloud and container. Well, that's good news. Looking at the results here, just give it a few more seconds.
Okay.
The reason being is that we had 92% for the last response, and we're up to 83. So people are just clicking through right now. And we'll close that off and share the result there.
90% on-premise still.
Oh yes, yeah. I fall into that category. I think all my customers are native installs, but we are getting people using the Amazon and other clouds for HADR even these days. So
that's great. That's great.
Okay, I showed that one. Let me hide that again. And are you using Blue today? Let's see what people say here. And got a number of people voted. Let's give it about another 5 seconds and we'll share the results of this.
Sure.
And there we go. Got some people using it for data warehouse.
Okay.
Not yet.
That's okay.
Yep. This is why we ask our audience.
Exactly.
And are you using DB2 containers? And there we have that. That's an interesting vote there. Thanks for voting quickly. We'll share the results there. On the low side of 50%, we've got people using
using the local host here.
Yeah, well, not yet, but planning to. So really, about 20% of our audience are using them today. It's interesting to note. And when you need support, this is kind of an interesting question. No. A little bit of reading here and figuring out how you really feel about things. So it's taken just a little longer. That's okay. And I only gave you one choice this time.
Okay.
So there you go. We'll share that one. Looks like support's doing pretty well. Occasionally people need to reach out.
Done some improvements there, close to 18-20%, but I think more than 80+% between support and development.
Yeah.
That's good to see.
Good. All righty. We'll hide that. And we'll move on now. You should be seeing my screen because the next person up there is you, Satya. And at this point, I will switch over. I'm going to be flipping your slides today, so we'll put your deck up here. I'll put you back, put myself back in presentation mode, and we're good to go. So
awesome.
What I'm going to do, Satya, just to remind you and remind the audience, there is a question and answer tool, and I will follow the cue and let questions come in, and but otherwise it's up to you, and that's great. Okay.
Okay. Awesome. Can I get started then?
Oh yes, please. I'm going to mute myself just so you don't hear any noises or things here, but I'll jump in.
No worries. No worries.
Thanks.
Yep. Okay. All right. Hey, thank you everyone for taking time to join this session. Today, I'm going to go through some of the Blue features we delivered in the last 12 months. We have tons of features that we have delivered, keeping quality as the #1 priority, but I'm going to keep it to the features that are delivered from my group within the DB2 organization. Martin, can you go to the next one? Next slide. Okay. So agenda-wise, we're going to talk about some of the catalog features that we are delivering in the coming days, and I will cover the storage and the compression features, also the runtime features. All right, we can go to the slide 4, Martin. Awesome, thank you. So there are several features that are coming out from the catalog side, but let me quickly touch on the rename feature that's coming out in December of this year. So rename table currently does not support any reference of the objects in views, MQTs, triggers, and some of the SQL functions. And a reason behind that is because of the inability to rename the references in the catalog and the compiler layer. So renaming table is one such restriction, especially when the table has indexes on expressions. So let's say when a customer creates an index on expression, so what the system does is it will automatically create a view with a select statement describing how that view column will be computed. So as you can look at in this example here, so we have a table T1 with 3 columns, and we created indexes on all of these 3 columns. So as you saw, the view that gets created automatically by the system there, and once that is done, when you try to rename the table, when you try to use the rename table statement on top of the table T1, it is not allowed, and you'll start getting SQL errors because it's a restriction. So the core changes to support this line item, what we're trying to do is it'll be done in the catalog services layer and also the compiler layer. So as you all know, currently the rename table, it's part of the standard DDL processing where it processes most of the checks between these 2 layers and calls needed functions to be done. So it will push those changes to the catalog side. In the process, if any view is encountered, it's just blocked at both these layers. I'm talking about compiler and also the catalog layer. And starting 11.5.7, we will remove the specific check in both the components. So from a user experience standpoint, this is just an extension of the existing functionality. So that means you as a user will have no impact to your applications. And also users, starting this 11.5.7, you should be able to create rename tables when you have indexes on expressions. And all the documentation changes that are required, they will be updated in the description of the rename table statement. And as you can see, it was a very painful process. So we took care, even though the change looks very small, it is a request that came to us from several customers. And we're happy to fix this and remove these checks in 11.5.7, which will be released in the month of December. All right. We can go to the next one, the catalog, the storage. Yes, next slide, please. Okay, awesome. This is a loaded slide. So before going into the discussion of the storage features, I would like to go through the details of how we landed with these features and the impact it had on our entire customer base. So looking at the first feature, right, the page-based string compression enhancement, and we call it type 1 compression enhancement. Excuse me. So initially, Db2 Blu acceleration technology, it used dictionaries with frequency-based encoding schemes to compress the data. And when we have high cardinality values for the string data types, such as the chars, the graphics, the varchars, the var graphics, the char for bit data, the varchar for bit data, all these are not being compressed well by the dictionaries. And what ends up happening? They are stored as uncompressed in the data pages, and the storage cost increases. And let me also give you an example. So for example, you have a product table, and it may have a store code integer column, and it can have many products located in the same store. Because the same store codes are repeated many times, the value in the store code column, it can compress really well with the dictionaries, right? But in contrast, let's say you have a product description column that contains free-flowing string values, and let's say it does not have any repeating values, and it does not have any common prefixes. So in this case, what happens to the product description column? It will be poorly compressed because the dictionary does not cover these types of strings. And we have seen this with a lot of customers, on-prem customers, and also warehousing customers trying to migrate from various appliance form factors to IIS, we internally call as IBM Integrated Analytics System, also called as Sailfish, or any DB2 warehousing environments. Especially when they're running into these high cardinality string values, they're not just compressing well, and this results in large amounts of storage, and it's just a added cost that they were not able to take care. So that's when our journey began. So we introduced a new feature that uses the page-based compression algorithm instead of a dictionary-based compression algorithm. And after this feature, the first feature, the type 1 feature, we started seeing significant performance improvements while compressing the string data types, especially when we're dealing with the high cardinality ones, that may have, no common prefixes, or it may have many unique values. And during bulk inserts and bulk updates, especially when you have large number of values inserted or maybe updated in a single transaction, we also saw great compression improvements for some of the data types, as we discussed earlier, the chars, the varchars, the graphics, the var graphics, the char and the varchar for bit data, and also binary, var binary, we saw great improvements. I do have some slides that I'll showcase the numbers there. But in terms of recommendations, if you're a customer migrating to the warehousing space or to one of our Sailfish environments, which is IBM Integrated Analytics System, we do have DB Migrate tools that takes care of this in the background. And our recommendation would be, if you have external tables, inserting from the external tables is a good practice, and also inserting from the columnar tables is a good practice. And from the problem determination and diagnostic tools, I'm sure you're fully aware of the tools that we have, the DB2 Darts, the Inspect, and the DB2 PD. They're fully supported if you run into any issues while using these features. And the best part is this is all automatic. You as a customer do not have to do anything. So we try to keep everything in a simple way so that you don't have to use this knob, that knob. So we try to keep it automatic as much as we can. And from a migration and a fallback perspective, So this page-based string compression features, it adds several attributes to the disk data structure. So it really does not impact the size of the data structure on the disk, but however, if you have customers trying to migrate to this new level containing this particular feature, you want to use it. So the fallback will cause those tables using the feature to be inaccessible. So just an FYI. So that's how we started our journey. And going into the type 2, the page-based string compression type 2. So this enhancement is a follow-on to the enhancement that we just talked about. So let me give you the details on how we landed on this one. So as we just discussed, right, the page-based compression, when it has the high cardinality and it does not have any common prefixes, we use the LZ4 compressor in the background. So that's the mechanism that we used. But certain types of data, however, they do not compress well with this LZ4 compressor. So what we have done in this enhancement, so we started building the infrastructure. So we built the infrastructure in such a way, so if we are trying to bring more additional compressors in the future, it will just make it easy from a development standpoint. So we built that infrastructure. And also in this enhancement, the good mechanism, the smart mechanism that we have implemented is, so before it writes the first chunk of the compressed data to a page, we will evaluate which compression method provides the best compression. So in the type 1, we have LZ4, and in this type 2, we have added the nibble code compression. So depending upon the data that is coming in, it chooses the best compressor and just proceeds accordingly. So as I said, we will then proceed with the best compression there. And the nibble code compression, what it does is it assigns a 4-bit code for each byte, and it improves 2x performance, 2x compression. And all the data will be stored in the page itself. And what is the impact of this enhancement? So we had customers that were struggling with the numbers, especially if there are serial numbers or phone numbers, or let's say we're talking about the dates, timestamps, times. All of these are being handled by the nibble code compressor. So that's how we started our journey with type 1, high cardinality with no common prefixes and all. Then we continued with adding the infrastructure and also adding the nibble code compressor. Let's see how we ended up with the third one. So the deferred synopsis table creation for small tables. As we all know that a synopsis table, it's a column organized table where it will be automatically created and maintained by the system in the background for you. And what the main purpose of this table is, it stores the metadata for any associated user-defined column organized tables. But what's happening with the synopsis table, or that they're consuming significant amount of storage, especially for the small tables. And the reason was due to the unused pages in extents. So by design, the first synopsis tuple is inserted into the synopsis table whenever the base table reaches 1024 tuples. So that's what we had as the basic design. So for example, for small tables, let's say you have less than 10,000 rows or less than 11,000 rows, the synopsis table may consume excessive amounts of storage because of the unused pages in extents. And luckily on the other side, we do not see this problem with larger base tables. And the challenge with synopsis table there is it does not really distinguish whether it's a small table or it's a big table. And that's why every synopsis table is created, after the base table reaches the 1024 tuples, no matter how much data that follows after that, right? So that's what we had in the initial design. So for this feature, what we have done is we increase the default tuple threshold, and the new threshold that we have set is 10,240 tuples. So the first creation of the synopsis tuple, it will be deferred until we meet or exceed this new threshold. So that's what we have changed in the design. And what's the impact of this one, right? So when you have small tables, it does not consume large amounts of data anymore, starting 11.5.4. And the first tuple, it will be a large range. As I said, the new threshold is going to be 10,240 tuples. And in the base tables, if they do not reach a certain size, it will just not have the synopsis table. And again, this is all automatic. All the features that I talked about, the type 1, the type 2, and the deferred synopsis table creation, these are all automatic, and you as a customer do not have to turn on any registry knob or anything. It's all automatically done for you in the background. And let's go into the reorg table recompress enhancement. This is a small enhancement that we snaked in between in 11.5.5, and this enhancement will recompress the beginning of the table. So whenever we create the dictionary, we have a threshold where we take a set of data and we compress using the data and we create the dictionary. So that the sample data that we take, it does not get compressed. So that's what we did as part of the small enhancement, where it takes care of the uncompressed data that we use the sample data by applying the type 1 and the type 2, the above features that we discussed. And you will also see a faster performance when you have the reorg recompress running. And again, if you want to run it manually, you can do it, but it's all automatically done for you in the background. So we do have a process that wakes up every couple of minutes, and it just looks at, hey, if there's any uncompressed data, and it will just take care of it for you. And the data types that will be covered, in the sample data, as we all discussed in whatever the types that we have in type 1 and type 2 enhancements. We're talking about, the chars, the Varchars, and if you have any graphic data, that will be taken care as well. And if you have any binary data, that will be taken care as well. Awesome. Actually, if you go before going into the Trickle feed, Martin, I actually wanted to go to the next slide to show them some performance numbers. Yeah, so as you can see from type 1 to type 2 here, 11.5.4, when we first introduced this feature, you can see the numbers. This is one of the warehousing setups that we captured this information from. Without the string compression and with the string compression, you can see the numbers are quite staggering there. Can you go to the next one? What?
Okay.
And this is for the type 2. And on top of the type 1 enhancement that we have already done, so you can see the number, how much it has improved in terms of the execution and also the storage space there. It's awesome. You can go to the next one. Okay. Yes. Next slide. Next slide. Actually, yeah. Slide 9. Yes, this is good. Thanks, Martin. So this is slide 9. Sorry. On to the next slide. Okay, sorry. Yeah, that's the slide. Yeah. Thank you. So the Trickle feed insert, this is one of my favorite features that we have launched as part of 11.5.6. And it was quite an effort our teams have done in the last 2+ years. And we finally released as part of 11.5.6. Before, as you all know, Trickle feed inserts. So that means if you're inserting a single row or maybe a few dozen rows, and especially when these inserts are happening into the column organized tables, we tend to find them very slow when compared to the row organized table. And there are two architectural reasons why this was happening when we first implemented the Blu. The insert code path itself. So what it does is it compresses each inserted tuple right away, and it also does it individually. So that was causing a lot of overhead. And the second design flaw we have is each external column, it belongs to its own column group. And what it does is it stores that on a separate column in a data page. And when this page requires a separate log record, and especially when you're dealing with wide tables, it just results in a significant overhead. And many customers, of course, our customers want a faster way of inserting small amounts of data. That's always the the requests coming out from our customers. But one of the use case that we have is from our IDA customer base. IDA is the IBM DB2 Analytics Accelerator. So it needed to replicate the transactional data from their DB2 ZOS host systems to the accelerator, which is where the DB2 columnar engine, the Blue engine, is located. So they want to do it as quickly as possible because they want their analytical queries, which are scheduled to run on DB2C. They want them to be delegated to the accelerator, which is where our DB2 engine is, columnar engine is. They want it to be done as quickly as possible. But because of these gaps that we had, it's slowing things down. So that was one of the biggest use case why this feature came into limelight. And the columnar, so this feature is called the columnar next generation insert engine. This solution will address the design flaws that I mentioned. And in this enhancement, what we're doing is we're using a new insert code path, and that structures completely new inserted columnar data in such a way that it is very optimal for all your trickle feed insert scenarios. So what we have done, if you can see in this diagram, so with this approach, we will see multiple columns, where they're grouped together into insert groups, and where each insert group page will be written completely uncompressed. And what it does is, after accumulating enough data into this insert group page format, so then the data will be compressed, and then it will be returned to a columnar format. And the best part is, whatever the insert group pages that are freed and available, they will be sent for reuse for future inserts. So that's the best part. And also this feed, it uses the existing bulk insert feature internally. So especially when it's trying to convert these insert group pages into a fully compressed column group pages. So all the features that we talked about, the page-based compression type 1, type 2, the deferred synopsis table creation for small tables, all these features will be automatically implemented and used. And my friends, you don't have to do anything. It is all automatic for you, and there's no manual intervention is needed. Especially, this feature is available in 11.5.6 for all our warehousing customer base, and we are in the process of making this available for our on-prem customers in 11.5.7. It is currently going through some regression, final batch of regression testing, and everything is looking great for the on-prem customer base. So if everything goes smooth, so we plan to have it available for our customers in disabled mode in 11.5.7, which is slated to release in December of this year. And that being said, there are a couple of insert scenarios that we can look into, right? If you're inserting into a table, if it's a small insert, less than a dozen rows or so, or even if it's a simple update statement, right? In this, what happens is they are typically inserted. Sorry, I'm getting a call. Sorry. In this scenario, what happens is these are inserted using the new trickle feed format. So that's what makes things going much faster. And also other insert scenarios that I can think of are, if you're trying to insert into a table with a simple select statement, select star from the table, these are considered as bulk insert operations as well. And also if you're trying to select star from insert into a table using select star from an external table. So these will be considered as, referred as the bulk insert operations. So any existing data stored in the trickle feed format, they will be automatically converted. And a few more insert scenarios that we can think of is, when you're trying to use the import utility, and when you're trying to use the CLA array feature, or the ingest that we have, and also the load we have, all these, we'll start using the insert trickle feed. And again, it's all automatic. You don't have to do anything, and it will be taken care for you in the background if you're a warehousing customer and sitting on 11.5.6. And our recommendation is always, the first recommendation that I can think of is use external table. That would be a recommended path to insert the data using external tables. And from migration fallback consideration, the DB2 warehousing customers don't have to worry anything about it. It's all automatically done for them. But for on-prem customers, the one thing that I want to mention is this feature is fallback incompatible. once enabled. So, and as I said, in 11.5.7, we are trying to push this feature to on-prem customers in disabled mode, where they will be given a registry variable because this feature is fallback incompatible once enabled. All right, next slide, please. So as you can see, the performance improvements, right? These are quite staggering, and these are some of the in-house performance numbers. I know some of the customers have come to us, especially from the IDA base. They said, "Hey, we have seen 30 to 40% improvements there." It's quite amazing what our teams have done in the last 2 years. And if there's the from a log reduction standpoint, we also seen some quite staggering numbers. There's 78% log reduction and 44% less page writes. And then we also had some of the healthcare industries. They came back actually showing us these results. Hey, we saw these quite amazing results. And again, I just want to repeat myself. It's all automatic for you guys, especially if you're on the warehousing space and using 11.5.6. So that's why one of the poll questions that we asked is, hey, what version of Db2 are you using? Because between 11.5.4, 5.5 and 5.6, they're one of features that we pushed out, be it performance, be it stability, be it all these out of memory situations and whatnot. At the ML optimizer stuff and also some of the optimizer related side, the runtime side, the features were quite staggering. All right. So that's all I have for storage. Martin, you want to take a quick break, 2-minute break before we get into the runtime features?
I guess we could. I planned on one, but then the slide deck wouldn't load, or the video didn't load. So I'm good without one. But if you need a quick break, I can say that.
I just need to grab some water.
Sure, but please do. It looks pretty good so far. We've got a lot of stuff going on here.
Yeah.
And but grab your water quickly, and maybe I'll see if I can find that slide deck while I'm here. Where did I put that thing? Here it is. Here we are.
Hi everyone, and thank you for coming to the DB2Night show. Today I'm going to show you the new DBI web suite. I'm going to show you the piece where you can take a statement that's not performing very well and run it through Explain and Design Advisor and see if you can improve the performance. So I'm going to go very quickly into the statistics. We collect statistics on everything that's running databases, applications, buffer pools, partitions. I'm going to go directly to the statements. I can see all the statements running in the database. I can see the different metrics. I can see the read efficiency. I can see that these statements have a major issue here when the read efficiency is very high, and you can highlight the different statements that have problems. I'm going to take one of those statements and I'm going to go and launch the workbench. The workbench, I can take a statement, run it, see what data I get from it, but I can also go and run the explain, do the explain plans. And the explain plan, I get an interactive plan here where most of the nodes will be collapsed to show you what's really important. When I click on any of those nodes, I can see the predicates, the properties, and the environment, and so on. I can also go into the design of the indices and run the design advisor. And the design advisor will run and show me what's the total cost before the advice and the total cost after the advice. Show me some savings. It recommends this index for me. I can go in here and I see what the index statement I can create it. So great. So now I took a statement and was able to get advice on it. But that's not enough. It's not enough to get an index, because an index might actually, creating an index on one statement might degrade other statements and cause a problem. So for that, we have a feature we can run index impact analysis on that statement. What will happen is the system is going to go find all the statements during the time frame, in this case, over the past 3 days, and run explain and advice on all of them, and find out if there are any statements that are degraded. Here I can see that one will be improved, great, and four other statements that are involved will be unchanged. Luckily, I have nothing degraded, so this is great index to create, and I can safely create this index without worrying about integrating any other statements. I can also see the total costs, cost benefits, how much CPU I'm going to gain, and how much I/O. I can see all that listed. If I see any statements degraded here, I can also go in and run the waypoint bench on that statement and in that statement. So very quickly, using few clicks, you can look at what the statements are problematic, run the design advisor, and tune them very, very quickly. Thank you for watching.
Okay, I'm back.
All right.
All
I
set?
got my water break as well. Yep.
Good.
We can move on to the next slide.
Right. There we are.
How are we doing so far? Good.
We're doing good. You've got some time, a good 20 minutes left, so we're in good shape.
Okay. Awesome. So I think we should be good. All right. So this slide, from the runtime standpoint, it summarizes a great story on how we evolved our Db2 runtime engine over the last 2 years. And in the last 2 years, in the CDE space, the column data engine, the internal objects such as the CDE vectors or the work unit vectors, what they do is they allocate and they store the wide data types, like when you're talking about the varchars, the var binaries. How they get stored is they get stored with schema column length as opposed to the actual length of the value. And the reason is they do not support storing varying length values. It's the biggest design flaw, unfortunately, that we had in the beginning of Blu. And what it does is this significantly blows up the memory footprint. And it started leading to out-of-memory situations or the disk pulls or the spill IOs, especially when you're trying to process large volumes of data. And we have seen this with several customers who are being challenged with this design flaw. And honestly, we really can pick on our DBAs when they define such columns with wider lengths, because they may not know exactly how wide each of the values in such columns can get to. And they obviously don't want to change the schema, right? And in some cases, the DBAs may not even have the control, because if the applications were developed by the business partners or the third-party vendors, so they just don't have the control over such things. In some customer scenarios, we were able to provide some workarounds where we requested them to use a cast or a substring so that it can shorten the width of the values, especially when we're dealing with these wide column types. But again, this is way too much work because it requires a lot of changes to their schemas and also their applications. This is how we started our journey on improving our efficiency for wider varchars. And this is a huge undertaking when it comes to development cost, and we attack this in a phased approach. So far, we have completed 3 phases and currently working on the 4th phase, which will be available in Db2 V12. That is currently slated for next year release, end of next year release. And the DBAs and developers out there, you guys don't have to do anything, man. It's all automatic, and it will take care of the 3 phases that we have launched so far. You guys don't even know, because we haven't even announced in the Knowledge Center, because it's all done automatically for you in the background. So we didn't feel to have it available in the Knowledge Center. And our internal code name for this project is called Compact Varchar, or we also call it CVC. So you might hear me say those terms several times in the next couple of minutes. So starting with the phase 1, the Compact Varchar, the vectors and the work units, we call it CVC phase 1. So we implemented a compact block store, and this compact block store structure, it is our building block for all the phases that we have, we are currently working on. It is the building block. So in this phase, we built that common infrastructure so where it can efficiently store and retrieve the variable length tuples. And it will also be pad-free, especially in the tightly packed compact storage. And what is the impact of this phase? We saw a dramatic reduction in memory footprint. We saw great improvements with the memory utilization. We saw reduction in spill fetch IO. We started seeing query performance improvements, and we also saw improvements with the overall workload when it comes to their concurrency and their elapsed times. So to wrap up on CVC phase one, so we delivered the compact storage solution for the vectors, the CD vectors, and the work units. And again, I want to repeat myself, this is all automatic. You don't have to do anything from your end as a customer. And going into phase two, the GroupBy and the HashJoin keys. We all know in any data warehousing or analytic workloads, join and GroupBy are the most two critical query processing operations. And the overall performance of any workload, it completely, especially if there are large workloads, it depends on their efficiency, scalability, and also their performance. So especially when we're dealing with exponential growth of data and combined with, this complex analytical queries, that's when the, stacks of join by and group by queries, join methodologies are used, they just start demanding more higher memory footprint. And when you combine this with the concurrency, it just pushes the memory footprint demand much, much higher. So the inefficiency of the memory utilization, we know what it will lead to. It will lead to reduced parallelism, especially when you're doing the join and the group by processing. And what ends up happening? Excessive spilling, reduction in concurrency, and overall performance of the workload gets tanked. And in some cases, you will also see out of memory situations. So that's why utilizing memory efficiently, when any query processing, it becomes very imperative for any database engine, especially when we're talking about the stability, performance, and especially when you're dealing with large workloads of data with complex queries. So we implemented in this phase two, we implemented an efficient and highly performant solution by re-architecturing the CD engine in 4 major areas. So one is the concat space, the other one is the compact hash table, and also the full compact storage support for GroupBy, and also the support for join using the existing hash table. And what was the impact of this phase? It's quite amazing. We saw dramatic reduction in footprints, overshoots, and out of memory situations that the customers are running into. We also saw significant improvements for the targeted queries and also the overall workloads in general. And we saw drastic reduction. This was one of the biggest phases that we released. We saw drastic reductions in spill and fetch IO. And the concurrency within the group by and join by has been tremendously increased. And the next phase, where we attack the compact hash table for AG distinct and OLAP count distinct. So in this phase, we improved the memory efficiency and overall performance, especially when we're dealing with the aggregation distinct and also the OLAP distinct CD queries. And the clause over there is especially when they have wide Varchar columns, right? And as a customer, again, you should be able to run complex aggregations, especially when the wide columns are involved, without running into any out-of-memory errors. Again, I want to repeat myself there. All of these features you won't even see in the info center because these are all automatically done for you in the background. All you have to do is execute your queries. And there's one more phase that I did not mention here, which is what we're currently working on. So we still have customers challenged with out of memory or poor performance on queries involving the wider HashJoin payloads, and especially when they have larger number of payload columns or wider payload columns. Since these are not padded to fixed length, and what happens is in our design, it also gets copied multiple times, especially when you're trying to process inner and outer joins. So it significantly, again, increases the memory requirement for all these joint hash tables and also the staging arrays, and completely impacting the overall performance of these queries. So we also done the market survey, and what we have observed is in the market, there is more than 60% of the analytical queries contain HashJoin. So that is the reason why we took up this critical phase that we're currently working on. And the impact that we can expect out of this phase, we will see, especially when you're, contains the HashJoin. We will see dramatic reduction in the memory footprint, the overshoots, the out of memories, and we are confident to speed up the hash joins, the performance of the hash joins, especially for the NM joins. And we will start seeing the drastic reductions in the spill and fetch IOs, and we'll also see improved concurrency within the hash joins, the CD hash joins. So that's the phase that we're currently working on. Again, this phase will be also made automatically available for our customers. We do not plan to have this updated in our info center because we will take care of it for you in the background. So that's what we have. Can you go to the next slide, Martin? Okay, as you can see the performance numbers here. When we released, I wasn't able to capture the phase 1 numbers, but I got the phase 2 numbers here. As you can see the numbers here, from a stability standpoint, all the customers that were hitting a lot of 901s, 955s, 968 errors, once they enabled this feature, they started seeing a tremendous 80 to 90% reduction in all of their queries, keeping the stability as number one quality. And also from a performance standpoint, we have seen some of the targeted individual queries run 12 times faster. What's staggering? And look at this, the buffer pool numbers. We saw 1200x less filling. And we saw the disk filling. I mean, once the feature is on, they did not even see the disk filling. And I actually wanted to give you an example. I can't really share the name of the customer, but it is one of the banking customers that I worked very closely over the last 2 years. And when they started the migration, they were coming from the Netezza appliance to the Sailfish, the IIS, where we have the DB2 warehouse engine, the Blue engine. So when they first started, one of their queries was running for 7-8 hours, and they were coming from a different environment, different warehousing environment where it was running for 4 to 5 hours. But when they came here, it's 2 to 3 hours above on their existing runtime. And when the first phase got released, we got the query down to 2 to 3 hours. And after the phase 2, the same query was executing in 35 seconds or less than 35 seconds. I mean, you can see the journey, how we started, 7 to 8 hours, got them down to 1 to 2 hours, and now it is running in less than 35 seconds. And as a customer, they didn't change any application, they didn't do any changes to their schemas, or they did not use any workarounds. It's just automatically done all of those things for them in the background. Can you go to the next slide? One. And the last phase that we released in 11.5.6, again, it's all automatic. The act distinct, as you can see, the performance-wise, we still kept on improving the stability, fixing the 901s, 955s, and the 968 errors. And also, we have seen some of the targeted queries perform up to 28 times faster. And we kept on improving the spinning to the buffer pool. We have seen in some of the targeted stuff 64x less spilling. And we also, every enhancement that we have done, we also took care of the spilling to the disk as well. So that's where things stand. Again, I want to repeat all of the features that I have mentioned between the runtime, the storage, and also the rename table. You as a customer don't have to do any changes to your applications or schemas or your queries, how they're running. It's all automatically done for you in the background. So that's all from me. Martin, I hope everyone enjoyed the show here.
I'll turn my microphone off, or on, rather.
Yep.
I'll take back control or put up my other slide deck for our closing remarks. Thanks for sharing that great information with us. We sure appreciate it. And let me just get this up. We've got one more poll to do, as I showed you at the beginning, which I'll do now, which is the famous, the one and the only, did you learn anything today? And so we're just waiting for people to have a vote on that. And the votes are coming in. I'll give it a little bit more time. And we're getting the answer we always love to see on this show, which is a 100% of our super audience learned something, which is what we would expect from a.
That's awesome. That's awesome.
Great show.
Has done a good job. Not a bad job.
Yeah, that's great. Well, once again, thanks for doing the DB2Night show. You're no longer an initiate to the show. You've been here. We'll look forward to having you back at some point. And
Absolutely.
with that, it's, as I say, the wonderful sunny day we're having here. What we're going to do is cue the theme music. I'm going to thank you profusely several more times. Wish everybody a great weekend. Oh, that really came on with a blast, didn't it? I'm going to get that guy not to do that with the music anymore, but I'll just continue to speak over it. Thank everyone for coming. So thank you, Satya, for a great job. And we'll look forward to seeing you next week for the DB2 ZOS Night Show.
Right.
Thank you all.
Thanks, Martin. Have a great day, a great weekend.
Bye.